So you have some Haskell experience and want or need to write some Scala code. The following is a rough map with the main differences, similarities, major gotchas, and most useful resources. In 2024, some projects still have not upgraded to Scala 3. Unless it includes the company you are working for, you don't need to worry about Scala 2. Most of the stuff here applies to both, we lean towards Scala 3 and explicitly describe both if there is a big difference. You should pick up all the syntax by yourself, but here's the things you should conquer first. Forget about reading code from right to left. You're not in the Haskell land anymore. Let's take this function as example. We have an error, we extract error message, put it in the left and then lift it with the pure. Scala, similar to Java, often chains from left to right. In this Scala snippet, once again we have error, extract error message, put it in the left, and then lift it with pure. But note that this time we read it from left to right. At the same time, you will often encounter code like this, which is not strictly from left to right. First we extract error message, then we go to the left to look at the left, and then we jump back to the right to look at the pure, or some other way around, get an error, jump to error message, go left, and then to IO. So why all of this? It's because the order and syntax are different due to using methods and not functions. Error message is a normal method on a class, the typical OOP. We have a class error, and each error has this method error message. Left is a constructor for either. Delay is a static method on a singleton object IO. You might have to look this up yourself to understand what a single object is, but long story short, there is IO and we can say IO.delay to do something and get something, almost like a function. Pure is an extension method for anything with an applicative instance. Like in this case, IO, use pure to IO. And the first method that we saw really relies on extension methods to get this consistent syntax. In this example, error message, normal method, and as left and pure are extension methods. It's not as complicated as it might appear, but just one more thing. In Scala, there are functions. We have function 1, which takes a string and returns an integer. Very boring, it just does a length. But as we saw, we also have methods, and we can convert methods to functions. We have a method on some temporary class. We can create function 2, and it's just a method. And we can use this method to create a function out of it. We can call a method directly, for example, with a test and get a 4, or we can call a function to get the same result. And note that it's a bit more verbose in Scala 2. You have to use new and you have to add an additional underscore. Even if you miss functions, you have to get used to declaring methods. And when needed, use them as functions. Might sound annoying and overcomplicated first, but the transitions are quite seamless, and I usually don't even think about this. So if you're new to object-oriented programming, good luck. See the official docs, write, read code, and give it some time. Functions in Scala are expressions, and their types can be often inferred. We can say function 2 is just TMP method, and it's gonna infer that it takes a string and returns an integer. But not all the time. For example, if we just say that we want lengths of something and we don't give any hints of the input or any types, Scala's not gonna like it. We have to help. When you declare a non-zero arity methods, you cannot omit the types of parameters. So if we take a string, we have to say that it takes a string, while the return type is optional. But it's usually a bad practice not to say what you return. Know how the unit return type looks like. It's not very functional, but something you might encounter, so know your enemies. On top of that, in Scala we can use default parameter values. For example, we can say the default string is hi and the other default one is world. And we can also use name arguments. This is especially useful with default parameters when we just want to specify one of them and how to deal with Boolean blindness and stuff like that. Another thing you can encounter in Scala is multiple parameter list. Instead of having everything grouped together, you can have multiple groups. When it comes to naming, Scala community has less tolerance for operators. It's more common to use for comprehension the do notation in Scala world. You might see some operators in DSLs in different libraries, but there are no fmap operator, there is just map. There is no bind or whatever applicative operators, but there are flat map and mapan. You can use flat map when you want to bind, you can use mapan when you want to do something applicative. And if you want parallel version, you can just say par mapan and keep the rest of the code. There is traverse, but there is no map-m, and you should look for traverse or for each, depending on the libraries that you're going to use. And we're going to talk about this later. Function composition is not very common. There are ways to do it. For example, you can use compose and then functions, but not that many people do it. Both currying and type inference in Scala are not helping either. You can query a function, but you rarely want to or need to. For example, we have a hello world function that once again takes a greeting and a name. We can make it queried by calling queried on it. So one is a function that takes a string, returns a string, and then we can apply one string to it and get a function that takes a string and returns a string, and then applies the string once again. But there is not much reason for it, because for instance, you can partially apply normal Scala function methods and get similar effects or results. Instead of having intermediate Korean, we just say hello, and then with an underscore we say whatever the rest, and then it's gonna give us a function to take a string and return the string. Kinda Korean, but not really. On a relevant note, get familiar with tuples and function parameters and how they play and don't play together. The triple question mark is almost like undefined, but not really. It's not lazy and not type inference friendly. It's just throwing an error. If I have some cache or a map from string to integer and have a function foo that takes a tuple of string and integer and returns an integer, we can say cache map and apply foo because it's a tuple, and maps map takes a function that takes a tuple and returns something else. So this works in Scala 2 and Scala 3, but in Scala 3 it's even nicer. You can take a normal function, takes a string and an integer, and apply it as well, and it's going to be smart enough to know that it's like a tuple, so it's going to work. In Scala 2 it's not going to work, and you have to be explicit. You can use functions like tuple to bridge the gap, and sometimes use more explicit parentheses. Scala is not Haskell. For example, you can add println anywhere you want, the blessing and a curse. So it's important to use a linter or some alternative way to enable recommended compiler options for FP Scala. Have a nicer subset and don't shoot yourself in the foot. For example, you can use this plugin for SBT, and it's gonna enable all the stuff that you want. And let's talk about laziness. If you want a lazy variable, see lazy val. If you want a lazy list, see standard library lazy list, or alternatives in other libraries. For example, you can check out if it's two streams. However, if you want another kind of laziness, make some thunks, write recursion, or whatever, it's not that straightforward. You have to be beware of stack safety. See cats effect IO and ZIO. We talk about IO later. You can also see cats eval data type or other alternatives that give you some data type to deal with laziness and strictness. You should also see tailrec annotation and tailrec m functions and other ways to trampoline and deal with stack safety. Also, beware of standard library features. They are very strict. Modules and imports. Good news, Scala has first-class modules and you don't need to qualify imports or prefix fields, and you can even nest them. You can have a bunch of classes inside classes and object inside object and functions inside functions and objects inside functions and whatever. Bad news, you have to get familiar with classes, objects, companion objects, and how to choose where to put your function and different kind of logic. Terrible news, you still have to worry about imports because they can affect the program's behavior. We talk about this in the implicit topic later. Scala comes with a bundle of immutable collections, lists, vectors, maps, sets, whatever. In the beginning, pay attention and ensure that you're using immutable versions and stay away from overgeneralized classes like sequence. Make sure to use concrete collections and the leaves of this graph. Also, be open-minded. In many cases, Scala has better methods and combinators than you might expect or got used to in Haskell. Here's another gotcha. In Scala 2, the multiversal equality was hell for me. I think it's pretty common to compare normal values to the values wrapped in options, but in Scala 3, it's not allowed. But out of the box, you can still shoot yourself by comparing case classes. So if you make a new data type A and make another one B, both take different types and compare to each other, just gonna tell us false. Good news, you can still disable it with strict equality compiler flag or via import. And then when we try to compare them, it's not going to work. However, for the Haskell developer, shouldn't be surprising. We just derive the way to equal. For example, standard library provides can equal, we derive can equal, and then we can compare stuff. But note that there are other alternatives and stuff that you can derive. When I was thinking about this guide a couple of years ago, I thought it was going to be the beefiest chapter. But luckily, Scala 3 is pretty good at type inference, so I have only a couple of examples. It's still not Haskell. Sometimes you need to help the compiler. For example, if you just say the identity function takes a and returns an a, it's not going to work. We have to either say that it takes an integer and returns an a, and then we have identity from int to int, or we have to explicitly say that it's polymorphic for all a, takes an a, returns an a, and then implementation also for all a to a. More annoyingly, it can come up during refactoring, so when you have some code that looks fine, and then we have a value where we create a foo and pass an empty set, and then we try to refactor it because set empty takes so much place, we put it in a variable, and now it doesn't compile anymore. Now we have to help and say that we want an empty set of integers. I'll just reemphasize once again, don't worry, in practice it's mostly good. For instance, using monad transformers used to be type inference hell. In Scala 3 it's fine. You put a bunch of either t's, mix IOs and all the stuff and it works. However, if you're on Scala 2, you might need to get in the habit of annotating intermediate values. Just be gentler to the compiler. Okay, union types. I think union types are great, but even union types need an occasional help. Imagine we have two functions. One returns a not found error, another one returns bad request error. If we use them together, we expect to have a union type myError, which is either not found or bad request. The straightforward composition of these two functions is not going to compile. We have to explicitly cast at least one of them, so we can say left widen to myError on the first case or the second case, and then everything's going to work and compile. Could be a bit annoying to get used to, but it kind of makes sense. Product types are not that bad either. You use case classes. For example, we have a user name, subscription ID. We create a user by passing all the stuff, and then we can say user.name to get a name. Case classes come with a copy method to modify fields. We can take our user, copy it, and change the subscription from one to another one. And 95% of the time, it's enough. When you need to, you can use optics, for example, via Monocle, or data transformation via libraries like Chimney. Some types are a bit more awkward. In Scala 2, we used to model some types with sealed trait hierarchies. For example, we have a trait role, which is either customer or admin or anonymous. And we used to do the same for actual enums. We can say that role is customer, admin, or anonymous this way, and then add some boilerplate to interrupt with databases or whatever, or use an enumeratum library which takes care of the boilerplate. This library was made as an alternative to Scala 2 built-in enumeration, but in Scala 3 we have nicer enums. Role is customer, admin, anonymous. Those are general enough to support ADTs. For example, let's add user ID back to customer, and we get an IDT. And note that some still use enumeratum library with Scala 3. New types are even more awkward. In Scala 2 we use value classes. For example, subscription ID is a string, but Scala 3 has opaque types. We can say that, for example, user ID is a string. But the thing is that by themselves, both are not very ergonomic and require boilerplate. So you need to either embrace manual wrapping and wrapping another boilerplate, or use one of the many new type libraries. I'm not even going to list them, there's a bunch. There shouldn't be anything too surprising about pattern matching. Just watch out for parentheses. If you want to pattern match on the option user, we just match on the user. And then we can also check if the name is not empty and ignore the field, and the otherwise case is done via underscore. However, you should know where pattern matching comes from. Scala allows pattern matching on objects with an unapply method. Case classes like user and enums like role we saw possesses it out of the box. But if we need to, we can provide additional unapply methods or implement unapply for other classes. In this still example, we have subscription ID, which is a string with a dash inside, and we provide additional unapply method where it's going to split on the underscore and just give us the rest, the number. So when we pattern match on subscription ID, we're gonna get just in part. This is important to know because libraries do it a lot. For more information, see extractor objects. Moving on, type parameters are confined in square brackets. Filter is polymorphic over A. It takes a list of A's and a function from A to boolean returns a list of A. Square brackets are also used for type application. If we want to create a new empty list, we say list.empty and in square brackets specify an int list of integers. I don't think it makes sense for me to go into too much detail here, especially given the difference between Scala 2 and Scala 3. Just a few things you should put into your hippocampus. In Scala 2, instance declarations are implicit. If you want a modded instance for option, you create an implicit and implement this. In Scala 3, type classes are more integrated. You write so-called given instances. In Scala 2 and Scala 3, context looks something like this. In square brackets, we have f, hierarchy f, and say they should have a modded instance. This f with a whole or f of a in Scala is as conventional as m and m of a in Haskell. Sometimes though, in Scala 2, the context is going to look like this. Instead of having modded together with f in square brackets, it's going to be specified in its own primary list as an implicit with a name. When it comes to instances, it's common to put them in the companion objects. For example, if we have case class user, then the object user is going to have instances. For example, JSON's codex. Another place to look for type class instances and implicit is object name something blah 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 implicit. For example, my something implicit. And then you can import and get all the imports. This means that you have to remember what to import, and imports technically affect the logic of the program. In application code, it used to be somewhat common, but seems to be less popular these days. It's still the way to get instances for libraries that integrate with other libraries. For example, Iron and Cersei. There's library Iron, and they have instances if you're using iron together with source, so you import iron and source together and you get the needed instances. In Scala 3, there is a special form of import for given instances. It's gonna be something like my_something.given. That's a lot and hopefully makes some sort of sense, but don't forget to read more about implicits or givens on your own. In Scala 2, the most popular ways to get instances are automatic and semi-automatic derivations. Those are colloquial names. Automatic derivation is when you import something and magically get all the instances and functionality. For example, for source JSON decoders, we say import source blah 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 auto, and then we can convert our case classes to JSON. Semi-automatic derivation is a bit more explicit. We import semi-auto from source, and then we create implicit codec by calling derive codec. And Scala 3 has type class derivation. Instead of doing all of that, once again we have a different import and we say derives codecs. In this case we're using configure codec, and if we want to configure it, we can configure it via this configuration. And note that you can still use semi-auto derivation with Scala 3 when needed. You should consult with documentation of concrete libraries. Metaprogramming. There are experimental macros in Scala 2 and multiple features in Scala 3. There is shapeless for scrappier boilerplate-like generic programming for Scala 2 and built-in shapeless mechanism in Scala 3, plus shapeless 3 for Scala 3. In Scala 2 it was common and is common to use shapeless and Magnolia for type class derivation. Scala 3 has built-in low-level derivation, but it's quite low level, so it's still common to use shapeless and Magnolia. Let's talk about best practices, starting with failure handling. Automatic Scala code does not use nulls, so you don't have to worry about those. Either is either, and maybe is called option. You might see try here and there, and if you do, see the docs, it's pretty much either, and see throwable, which is a cousin of exception and some exceptions. For everything else, see what your stack or libraries of choice have in terms of failure handling. There existed a lot of different Scalas throughout the years. In 2024, FP-leaning, industry-leading Scala converges into two: type level and Zio or Zero stacks. Roughly speaking, both come with their own standard library or prelude, IO runtime, currency, libraries, and best practices. Yeah, Scala standard library is quite functional, but not functional enough. That's why we have these auxiliary ecosystems. Even more roughly speaking, if you're leaning toward using MTL transformers, start looking at type level stack, and if you're leaning towards using app monads with baked in either T and resources and other batteries, see Zero or Zio. There was a moment when people used free and effect system in production Scala code, but it sucked. So I don't think anyone uses either of those in production these days, which is different from library world. Some library authors still use free. Also, there is this hype train forming around direct styled Scala. Actually, there are multiple trains because the term is so ambiguous, multiple styles packaged and sold under the same name. But if you're curious, you have to look into this yourself. Because if you get an FP Scala job around 2024, the newer services are going to be written using type level or Zio. And there are probably going to be some legacy code in other styles, but let's focus on these two. Type level or cat stack, because the cats and cats effect are the core of the type level stack. One provides function programming abstraction, and the other one provides IO and effect type classes. The other two pillars are FS2 and HTTP4S. Functional effectful streams on one hand, and the functional HTTP library on the other hand. The other go-tos are source for JSON, Doobie for databases, and another examples like cats, MTL, and whatever. Note that nothing stops you from using alternative libraries or additional libraries, especially if they provide required instances and interrupt. For example, it seems common to use Tapir instead of or on top of HTTP4S for writing HTTP servers in the last years. Tapir integrates with all major stacks, so you can use it with cats and Zio and whatever else you have. Going back to type level stack, it's common to organize code via so-called tagless final, which is gonna be based on interfaces like this, but you should look it up yourself. It's common to tie your app together via resource. We create all the resources that we need, tie them together, and then let the resource handle everything that we don't care about for us. So we can focus on the logic and not on opening and closing stuff. It's also common to write some, if not all, business logic and organize control flows with FS2 streams. Like in this example, we fetch subscription from some URL, then we add some logging or whatever reporting, parse the subscription, remove broken subscription or invalid subscription, and then in parallel do more stuff with more data and so on and so on. Zio ecosystem comes with a lot of batteries. The ZIO is the main data type that has 3 type parameters, for environment, for the failure, and for the success. It's a core data type in the sense that it's also the way to organize the code, it's the way to deal with resources and scopes, control flows, and so on. Just see the usage. See the usage for the usage examples. Let's quickly go through tooling. You can use Coursera to install Scala tooling GC app style. I've never used anything but SBT with Scala. If SBT does not work for you for some reason, I cannot help you much. I cannot help you much with SBT either, but see other Java build tools like Maven, or multi-language build tools like Pens or Bazel. Other toolings that you should check out is Scala CLI, Scala worksheets, and Scasti to share your snippets online. If you need to search for functions, there is nothing like Google in Scala world. The dot completion and the go-to definition for libraries often work, but honestly, I regularly search through GitHub looking for functions and instances. I don't know what normal people do. When you're searching for libraries, you can start by searching in the organization or project list, the one we saw for type level project and then Zio project. You can also search on Scaladex. It's quite similar to searching on Google, but you can always search on GitHub. If you have not found anything there, you can always ask your friend or just use a Java library. The interrupt is quite seamless. When it comes to managing and dealing with dependency version, there is no stackage. Some people use SBT lock and SBT dependency lock plugins to get lock or freeze files, but a lot of people use Scala Steward. It's a GitHub bot that helps keep dependencies up to date, so you're always on the latest versions. But if this automation is too much, you can always fall back to checking the Maven repositories to see what are the dependencies. For example, if this appear libraries and if we have any conflicts, and we see all of its dependencies and we can do all the investigation that we need. If you want to learn more, see docs at scalalang.org, check out rocksthejvm.com, and the foundation of functional programming in Scala. The last one is a free course on YouTube, which is really good. I used to recommend Underscore's books to Haskell devs, both Essential Scala to learn Scala and Scala with Cats to learn the FP side of Scala, but those are for Scala 2. The classic functional programming in Scala, some people call it Red Book, has a second edition updated for Scala 3. It's great if you want to dive deep into the FP side of Scala, and FP in general, if you're not there yet. If you want to get weekly Scala content, see Scala Times newsletter and This Week in Scala. If you want to chat, see scalalang.org community. When it comes to the OOP side of Scala, I think the most important one to get familiar with is variance. You might think you won't need it if you don't use inheritance to mix list of cats and dogs. However, you'll still see those pluses and minuses around and encounter related compilation errors. More and more libraries go out of the way to deal with this, so our life is easier, and you might not even need to worry about it for a long time, but you should probably check it out. Good news if you're familiar with functors. Depending on how well you're familiar with functors, it might help or hurt to apply the knowledge of covariance and contravariance here as well. And a few things that you'll need sooner or later. You might encounter different subtyping related type relationships. If you encounter this set face or the happy one, search for upper and lower type bounds. If you encounter something that looks like associated type, see abstract type members. And if you encounter an asterisk, for example, like in this array apply constructor, or used as a splice in parameters, like in this constructor, or in splices, see var args. And congrats, you are one step closer to mastering Scala. Just a few hundred more to go.